Wrote the statement. In support, draw this diagram, not the question. Just this diagram. Monica completed?
Yes, sir.
Try to answer this question now.
So the point P dash will be -3, -2, and point A dash will be +3, -2.
Rethink about A dash once again. Which quadrant is A -3, 2? Original point. Which quadrant it is?
Second quadrant.
So where will be the image go?
Fourth quadrant.
In fourth quadrant, how will it have -x?
Sir, I said +3, -2.
Then it is correct.
Sir, I said that.
Sorry, I heard it's -3, -2. Then that's why I said rethink about A dash.
Sir, actually my tongue slipped.
Yeah, I know. So where is the point P 3, 2 here? We are talking about this example only. So when I reflect it, it will go to the same distance. This is P dash. This height is 2 and this is 3. Origin A. So here it will be origin B. So this will be 3 units opposite, 2 units below. That's why P dash should be -3, -2. Whereas when I consider A, which is -3, 2, originally it is here. A is -3, 2. So where will be the image? It will go into fourth quadrant. This will become A dash. Oh, I already used the name, so I'll call it Q here. Right. Now this point is -3, 2. So this side length is, and this height is 2. That means when I drop perpendicular from here, again this height should be 3 and this should be 2. That's why then it should be 2 in the decreasing direction, negative y-axis, but x is now in the positive direction, which is increasing. So it is 3, -2. Abscissa also changes the sign. Ordinate also changes the sign. So any doubt regarding reflections now? X-axis, y-axis, origin. 3 reflections. Is this clear to all? Can we move ahead?
Yes, sir.
Okay. You can mention these properties. Say I have x-axis and I gave you a segment AB. Till now we are reflecting points. Now what is reflection of this AB segment? that will also be equally inclined, and it will be like this. So this will be B dash, this endpoint will be A dash. Now reflection of a line segment is done by finding the image of endpoints and then joining these images. So if suppose there is a line segment which is joining 1, 4 and 3, I'm joining these two. How will be the image reflections now? With x-axis or y-axis for that matter, anything. Just better, so I took x-axis. So the image of the segment will be A dash B dash. What will be A dash point reflection with respect to x-axis? So what will remain same and what will change?
So
Abscissa remains
y-axis.
same. And
So
B
the
dash should
ordinate will
be,
change.
coordinates will change. Abscissa remains same. Same is the next property. Reflection of a triangle or any rectilinear figure is done by finding the image of the vertices. So say this side I have drawn a triangle like this, some triangle, and I consider y-axis as a mirror, and I want to draw the image. What will happen to the image? Say these 3 points A, B, C. A as it is will be reflected. It will be somewhere A dash. C will be reflected. It will be, say my diagram is a little, I'll change it. A will be reflected, it will go somewhere here, it becomes A dash. C will be reflected, this will be C dash. B will be reflected, it will go to B dash. So when I join these three, what I get is the image of this diagram on y-axis. What will be the coordinates? Suppose this is 3, 5. This is 2, minus 1. And this is minus 3, 5. Minus 3, minus 5. Then how will be A dash coordinates? Each point one of you each. With respect to y-axis, we'll start with Alethea. What will be A dash coordinates?
3, 5.
3, 5 is A. What will be the image in y-axis?
I didn't understand the question, so can you elaborate?
Nice. A is 3, 5. Okay. I'm reflecting it with respect to y-axis. I need the name of A dash point.
So minus 3, 5.
A dash will be minus 3, 5. Alethea. What will be image of C? Others just mention it in your notebook. Don't worry.
Minus 1.
Minus 2. Minus 1. Sahas. What should be B dash coordinates? You can type. What happened to Sahas? Okay, Milan. What will be B dash coordinates? Sahas is trying to reconnect. Bhumika, what will be B dash coordinates? Yeah, Sahas, you can speak. If you are comfortable, then speak.
Say, will it be say 3 comma minus 5?
3 comma minus 5. Now that triangle formed B dash C dash will be the exact image of the original triangle, which is AB. Now what these two properties says is, if you want to reflect a diagram in any axis, then you simply take the images of individual vertices. Triangle, 3 points, A's image, B's image, C's image. Join them. You'll get one more triangle which you obtained by images will be the image of the original triangle that you have reflected, whether it's a line segment, or any rectilinear, quadrilateral, pentagon, decagon, any diagram. How do we find the reflection? Simply reflect each of the vertex in the running axis. There will be new points formed. Find them. The diagram you obtain will be the exact image of the original diagram. Is the idea clear?
Yes, sir.
Write down both the properties. Reflection of a line segment is done by taking the image of endpoints, and reflection of triangle or any rectilinear figure is done by finding the image of all the vertices. Milan completed. Can we move ahead? Yeah, write down slowly, no problem. Write down. Bhumika completed.
Yes, sir, completed.
Good. Leafia completed.
No.
Yeah, mention it. Idea is clear now, right?
Yes.
Yeah.
Now I'm done.
Good. Sahas completed. Mark, noting down. Milan, can we? Milan completed. That's an important note again. When the line PQ is parallel to y-axis, the axis of the points P and Q will be equal. Say I have same like x-axis, y. I have a point P here. This is x1 comma y1. What is the theoretical one? The distance from this point to x-axis, say D, and this is say A. Then this height is y1 and this length is x1. Now where is the second point Q now? The line PQ is parallel to y-axis. That means the point is now somewhere here, Q. And the name of this point is x2 comma y2. And what I know is this line segment PQ is parallel to your y-axis. Forget about PQ is parallel to y-axis and all. There is a point Q whose name is x2 comma y2. What does it mean? The distance that you draw from x-axis, say point C, this should be x2, and from Q right down here should be y2. right? This is the original meanings of the points P and Q. Now observe the diagram. Can I say PB length and QC length are equal? Because these two lines are parallel. Y-axis and PQ are parallel. Distance between the parallel lines should be equal. So PB and QC must be equal. It means X1 is PB and QC is X2. So first point here to important to note is, if the line is parallel, then the abscisses are equal. Now observe the same diagram again. Length PQ. Can I rewrite this as QA minus PA? QA, this total length, minus PA. What I am left with? Am I not left with the length PQ? Right? Now what is QA length? That height is originally Y2. What is PA height? That will be Y1, P's height. Now why I use the symbol modulus is, you know how a modulus behaves, right? It takes away the negative sign. If there is a number which is in minus, then with the modulus the minus will disappear. Why I don't want minus point could be down below P, or Q point can be above P. So when I write difference of abscissa, ordinates, I should not get the length negative number. That's why we use modulus Y2 minus Y1. Otherwise what will happen? It will become Y1 minus Y2. If Y2 is below this and somewhere here, then I need to write Y1 minus Y2. So just to cover both of them, we mentioned. Now, is this two properties clear to all of you? Observe the diagram, clearly see what I am writing. If you can relate, then only you mention it in the notebook. First, you confirm that this idea is clear. 2 points in the same slide. One is parallel to y-axis, abscissa remains same, and the length distance will be equal to difference of ordinates. Is the two ideas clear to all?
Can you repeat the property, sir?
If the line is parallel to y-axis, first condition is the distance from y-axis should be equal.
So
The
can you
distance
remake the
from-
diagram?
You want me to redraw it?
So can you re-explain it, sir, because it's confusing.
Yeah, I'll do it. Okay. There is a point P here. Name is x1 comma y1. Some number x1 comma y1. What do you mean by the point P? x1, y1. If I drop a perpendicular, then this height, say A point here, then this height should be y1 and this horizontal distance should be x1, P point. Is this clear to all? This is just naming of the point P only. What we wrote on the board is should be clear. Now what I'll do is, I have another point here whose name is Q. Of this point y2. Forget about P's existence here. P is not there on the board, only Q is there. What is meaning of the point? From y-axis, if I draw perpendicular, say C, this is x2, and this total height from Q point to the point A, this total height is y2. Is that idea clear again? Alicia?
It's clear, sir.
Yes, sir.
We are clear so far. Now look at the first property, condition. He says PQ line is parallel to y-axis. If the line P is parallel to y-axis, then can I write CQ must be equal to BP? Because these two lines, PQ line and my y-axis, are parallel lines. Then distance between the parallel lines should be equal. Distance between the parallel lines, one length is CQ and another length is PB. They both are equal. Is that clear to you both?
Sir, so the abscisses are equal.
My CQ is nothing but my X2 and BP is nothing but my abscissa Sorry. X1. So the abscissa should be same. Is this idea clear or no?
Yes, sir.
Now, Alifia, is this idea clear? Abscissa equal if the line is parallel to
Yes.
y-axis. Is that idea clear?
Yes.
Very good. Now, this is the first property. That's the first point. Now, what I am saying is the second point is I need length PQ. Look at the diagram. Can I write PQ as QA minus PA? But what is QA? That is height of the point Q. That means it is y2 minus what is PA? That is the height of the point P, which is y1. That's my second property. Is this clear or no now?
Yes, sir.
Alifia?
Yes, sir.
Now Milan and Sahas also. Is this idea what we are discussing, is that clear? Yeah. Good. Now coming to only one point that is missing is why this sign. Do you know what the modulus behaves? What is the behavior of modulus? If I put say minus here, it will give me plus 5. Modulus will eat away the negative sign, or removal of the negative sign in mathematics is called modulus. Why I used this here is I have only one condition, PQ is parallel to y-axis. Do I ever mention that P is below and Q is above? It can also be possible that P is here x1, y1 and Q is here x2, y2. X-axis is here. Now this height is y1 and this height is y2. Now what will be the length PQ now in this case? In the second small diagram that I have drawn, what is peak length? Total height is
Y1
y1.
minus Y2.
It should now become y1 minus y2. And the difference of this y1 minus y2 or y2 minus y1 is only a minus sign. So because I don't know whether P point is above or Q point is above, this is not mentioned here. I gave just PQ line is parallel to y-axis is mentioned. I might differ in a minus sign. Instead of writing 5 minus 3, I may write 3 minus 5 because I don't know which point is above and which point is below. But here I'll get 2 and here I'll get minus 2. But distance cannot be negative. That's what we do is, if it is unknown, which number is bigger, y1 is bigger or y2 is bigger. If this idea is not known to us, but I know that finally the subtraction should give me only positive number because distance cannot be negative. Then what we do is we denote it with modulus sign, because modulus is such an operation that it will you only with plus value. So modulus here is only to tell you that in case if you get a negative value, put it inside modulus and it will give you positive value. Is that idea clear now?
Yes, sir. Perfectly
Now
clear.
clear? Write both the complete statement clearly, and if you want, draw the diagram also. Not if you want, you have to.
Already made, sir.
Good. Milan and Sahas wrote the statement. Alifia, now is that idea clear to you?
Sir, I got disconnected because of my network. Can you please just repeat in brief?
Yeah. Is this y1 minus y2 clear? This y2 minus y1, is this idea clear?
No, sir.
This QA minus PA.
Yeah, that's clear.
Now, only thing you are not clear is why this modulus sign. I mean, what does this do, right?
Which modulus sign, sir?
I mean, in the formula when I wrote mod of my y2 y1. Why we use this symbol, two vertical lines on either side, is this sign, two vertical lines, has a specific character. If you put any negative number inside them, they eat away the minus sign and give you a positive number. It's a mathematical operation. Why I brought it into this formula here in particular is, don't get any confusion in it. But why we used this symbol, distance cannot be negative.
Yes, sir.
Distance between 2 points, it cannot be negative. So that's why we use, to tell you that distance cannot be negative, we use this symbol modulus of y2 minus y1. Is that clear, Alifia? It's a symbol.
Yes, sir, it's clear.
Write down that statement, draw the diagram and finish it. Milan, done? Do it. Bhumika?
Yes, sir. Completed.
Right.